let's start by looking at this fraction. And so with this fraction that I just showed you, this is what I want. I want you to write what the fraction is on the back here. Write the fraction, tell me what the unit fraction is that goes with it, and decompose it in one way.
Then do we show you?
Yes, on here.
Okay. Wait.
Write down what the fraction is, tell me what the unit fraction is, and then decompose it. And really, you know what? I'm going to change it because there's only one way you can decompose it with that one. So here's the fraction. That's better. And again, this should take about 1 minute. And I'm going up and down video feeds to see who's showing me. Hold it up as soon as you got something to show. You don't need to copy this picture. You just need to write down the fraction it shows, write the unit fraction, and write one way to decompose the fraction. Joseph, I see your video up. Are you showing me? You got something to show me, Joseph? I'll come. Got something to do here. Okay, people should be done and ready to show me.
I forgot, what were we doing again?
Now listen, dude, you got to listen. You are writing down the fraction you see here. You are writing down the unit fraction, and you're writing down one way to decompose it.
Okay.
Alexa, I see the fraction good. I see the decomposition good, but I don't see what the unit fraction is. I'm looking. I can't see everybody at once. I forgot about the good. It's not equal. They're not, but the fraction and the unit fraction are not equal. And that's actually not the unit fraction, Lexi. Okay, good, but they're not equal. To have an equal sign between them would not be correct. Okay, I've seen it from Lexi. Let's see, who else is holding theirs up? Let's see. You don't need to draw the picture if that's what's taking you so long. I didn't want you to draw the picture. No. Who wrote? Is that 6/8 that somebody wrote? Because that wouldn't be correct. How many parts are there? 1, 2, 3, 4 parts. No, 6 parts. I mean, there's one. Sorry. So there's 6 parts. 1, 2, 3, 4, 5, 6. And so if you're going to show this fraction, there's 6 parts. 1, 2, 3, 4 of them are colored. That's 4/6. Now a unit fraction. So with this, we're working with 6. Remember, unit fraction, I'm asking what's just one of these parts? Well, one of these parts would be 1/6. So the unit fraction is 1/6. And then a way to decompose it, 4/6 equals 2/6 plus 2/6. 4/6 equals, you could do all unit fractions. You could do 4/6 equals 2/6 plus 1/6 plus 1/6. And then the last way, 4/6 equals 3/6 plus 1/6. Like that. All right. Here's what we were talking about yesterday. Let's say we have one whole rectangle. Okay, we would agree that this is one rectangle right here. And I'm gonna color the whole thing in. I'm gonna color one whole rectangle. You guys don't actually need to be doing this right now. You just need to be watching me. So there's one whole rectangle. Now the question I want to ask you, how many fourths are in this one whole rectangle?
4/4.
Alexis says 4/4. So Joseph, what do you say? Do you agree? Joseph is giving the thumbs up. He agrees. Jose agrees. Sebastian, not sure what you think. Good morning, Miss Baggett.
Hello. Good morning, Mr.
You know-
Jensen. Hello. Good morning, class.
You don't mind, Miss Baggett. I know you've been doing a lot of sitting and watching, but I think it's best for this stuff that we all just stay together for it. So
What do you mean? I've been here. What do you mean stay together?
yeah, I mean you're here, but I'm saying I've been keeping everyone together instead of sending, Vernell and Dan and Anthony off with you. I've just been keeping them together, and I just hope you're okay with that, just because.
Oh yeah, no, yeah, you make the call. No, that's fine.
All right. So those of you who said there's 4/4 here, I would agree. So if you took this and you split it into fourths, then you can see, yeah, there's 1, 2, 3, 4/4. And also if you let's say we split it into eighths. Well, then 1, 2, 3, 4, 5, 6, 7, 8, 8/8. And then let's just erase it and start over. What if I have the whole thing's colored in again? I wish there was a quicker way to color it in. Let's say I have, this is 1 again, and I split it into thirds. Now I've got 1, 2, 3 thirds, right? So anytime you have one whole, you're going to see that you could also write it as a fraction where the numerator and the denominator are equal. All right. Any fraction, can we see now? Any fraction where the numerator and the denominator are equal is equal to 1. So 1's equal to 3/3, and it's equal to 1/4, and it's equal to 8/8. And then if we look at our chart, we could see that 1 is also equal to 5/5, and it's also equal to 2/2, and it's also equal to, let's see, what else? Well, the 6th, there's 1 6/6. 1 is equal to 6/6. 1 is equal to 10/10. 1 is equal to 12/12. Any fraction where the numerator and the denominator are equal, that is the same as 1. That is equal to 1. So what's the point of that? Why am I talking about that? Let's talk about it. Well, this just shows that how we can decompose 1. So like, let's say we have 1 here. Well, let's think of all the ways. Let's say we can decompose it into 6ths. Well, we could say 1 equals 2/6 plus 4/6, right? Because that would equal 6/6, which equals 1. Or we could say 1 is equal to 3/6 plus 3/6. That equals 6/6. Or maybe I said decompose it into fourths. We did fifths. Well, we got 5/5 here then, right? So that means we could decompose it into 2/5 and 3/5. We could do all unit fractions like that, right? Any number, pick a denominator. Somebody give me a denominator to decompose.
8.
Eighths. Okay, we're gonna decompose into eighths. So who said that? Was that you, Donald?
That was me, Alexa.
That was you, Alexa. So Alexa said, let's decompose it into eighths. Well, how many eighths are in here? I'm gonna ask Hallie, how many eighths are in one rectangle? How many eighths make one rectangle?
8.
How many, Hallie?
I didn't say anything yet. I was thinking.
How many eighths make one rectangle, one hole?
Oh, can I say it?
Really understand.
Hallie, look, are you paying attention here? Here's one whole rectangle, right? This is all in the one. How many eighths do we have here?
8.
Eight eighths. Weren't you here when I said that one's equal any fraction where the numerator and the denominator are the same is equal to 1. So you should know right away. If Alexa says, let's decompose it into eighths, well, if this is one whole, then we've got 8 eighths in here. We've got 8 eighths. So what's one way we could decompose that? Well, we could do what equals 8? 2 and 6. 2 eighths plus 6 eighths. That equals 1. How else could we decompose it? I'm looking for volunteers. Donald, how else could we decompose it then? Don't know or not paying attention, Donald? Not sure. Remember, 1 is equal to 8 eighths, right? So what else can we add up to make 8 eighths?
4 eighths and 4 plus 4 eighths.
4 eighths and 4 eighths. Yep, that works. Good. If it helps you guys, think about it first as 8 eighths. Right? 8 eighths. And also remember that we're thinking about 1. So 1 equals 8 eighths. What's another denominator that we could break it up into? We've done eighths, we've done fourths.
Separate these out to get to this sum.
I don't want to hear what Miss Beck's teaching. So what's another one? We've done eighths. Let's do another one. What's another denominator we could break it up into? Jose, what do you want to do? We've done fourths, we've done eighths. What do you want to do? Which denominator do you want to decompose it into, Jose?
Tens.
Tenths, okay. So, Jose, if we're going to do tenths, how many tenths are in here?
10 tens.
Very good. So this is 10 tenths, which equals 1. So we're decomposing 1. So what would be one way we could do it, Jose?
5 tens.
5 tenths plus what?
5 tens.
5 tenths plus 5 tenths. Very good. So then what's another way we could do it? Let's ask Santino. We're doing tenths, right? Hey, Santino. Santino.
Yes.
That's another way we could decompose it into tenths.
6/4.
6/4 would not be right. We're working.
I mean,
with
6 tenths plus 6/4.
No, not 6/4. 6 tenths plus what?
4 tenths.
4 tenths. 6/10 plus 4/10. Yeah, pay attention, Santino, so we don't have these long waits. So we get the idea. All right. Let's look at something else now. We know that this is 1. All right. Let's color this green. So we've got 1 whole colored green. And then what fraction is colored green down here?
1. I mean 1/3.
So we've got 1 up here and we've got 1/3 down here. So how many thirds do we have in this picture? First of all, let's figure that out. Let's ask Christian, how many total thirds do we have here? Start with how many thirds are up here in 1 whole. Christian either doesn't know or is not listening. Joseph, how many thirds are up here? Hey, Joseph, am I 0 for 2? Joseph either not listening or not paying attention. Hallie, my 3rd try. How many thirds are up here, Hallie? 1 whole.
3/3.
3/3. And we got 1/3 down here. So how many thirds do we have in all?
1.
No, how many thirds? How many thirds are there?
4.
4/3. So we've got 4/3. And let's look at this fraction, 4/3. This is called an improper fraction.
How did you guys get 4/3?
What?
Never mind.
No, what was your question?
How did you guys get 4/3?
How many thirds are up here, Lexi?
3/3.
And then how many are here?
1/3.
So 3/3 and 1/3. How much is that?
4/3.
There you go.
Oh.
So an improper fraction, that's a fraction with a numerator that is greater than the denominator. And I'm going to take a picture of this and put it in Seesaw. So we got the improper fraction, which is a fraction where the numerator is greater than the denominator. Let me get a picture of this. You could say that this is 1. Hold up. I'm going to take a picture of this and I'm going to erase it because then we're going to write something else. So hold up, everybody. Say cheese. Click. So I got that. Now let's take this out. So we know that this is 4/3, but then it's something else too. Again, anytime numerator and the denominator equal, we just call it 1. So we could say we've got 1 here, and we've also got 1/3, which is 1 and 1/3, right? And 1 and 1/3, anyone remember what this is called? A number like this, 1 and 1/3. I need to write this better. Like,
Unit fraction.
no. I mean, this by itself here, like that, that's a unit fraction. Lex.
Improper fraction.
No. We got a whole number, right? And we've got a fraction. Remember, this is called a mixed number. This is a mixed number.
Oh, yeah.
And a mixed number is, it's a a number that has a whole number and a fraction. So it's mixed. It's a mix of a whole number and a fraction. All right. So let me get a picture of that. And this is going to go in the seesaw also. And smile. So what's the point I'm making? Well, we could say this right here, couldn't we? It's 4/3. 3/3 plus 1/3 is 4/3, but it's also 1 1/3. It's also 1 1/3. So to call it 4/3 or 1 1/3, those two are equal. So you're going to find that any improper fraction is going to have a mixed number that it's equal to. And any mixed number is going to have an improper fraction that it's equal to. One of the things that we might work on in 4th grade is knowing when to change them back and forth. When you might want to change this into that, we might want to change that into this. So, but for our purposes today, we want to talk about how we can take a number like this, like a mixed number like 1 1/3, and decompose it. Okay, which we had been doing a little bit. We're going to do it some more after lunch. All right. So right now it's 11:25. I'm gonna let you go like 5 minutes early because to start that next part, I don't want to start it with like 5 minutes left and then try to continue it then. That's no good. So we'll just go to lunch now and then we will start it right after lunch at 12. So you need to be back here on time. All right. Any questions so far? No? Good. See you after lunch.